Hi everyone, welcome back. In this video I want to make an example by using Cuda language. It means we are gonna use GPU. Cuda language is important because it's directly reaching to the GPU. Also in some cases opencv or other kind of libraries cannot directly reach to the GPU because they don't have they are not compatible, some functionalities not compatible with Cuda. So directly using Cuda language in most of the cases is gonna be helpful. Also, there are not many resources in the internet, so I believe this is gonna be a helpful video. Okay, so in this video, for example, I just want to use Sobel filter. So first of all, I'm gonna implement the code from the scratch via on the Cuda language. Also, we are gonna see the interaction with C++ and the Cuda. So we are gonna implement that because just Sobel filter is a simple filter, and at the same time, at the end, we are gonna apply the same Sobel filter via on the opencv side, and we are gonna compare the time, how the time changing from, because opencv of course gonna use the CPU, so we are gonna compare the time and the results. Okay. Also, since I'm using Qt, but normally you cannot directly compile this Cuda file in Qt side because Cuda can be only compiled with MVCC, but normally Qt is just using GCC. So this is an issue in the Qt side. Just I like to use Qt. I just searched in the internet and I found this topic in the forum. According to this, since this guy already implemented how to use in Qt, I also get the same profile content. I just changed in my site, so it was working fine. Also, I'm gonna put this code into my GitHub. Also, I'm gonna share that topic in this YouTube description. Okay, basically that just including these complicated things in the pros file side is basically just linking Cuda libraries into the Qt. Okay, only issue I get in during this, I just changed my GPU architecture because in that case something different. In my case, my GPU architecture is 8.6. Also, you can check your architecture simply via on the terminal and just change here accordingly. Okay, this is the important thing. I just linked opencv and Cuda into the profile. Okay. Also, I create a simple Cuda file and also header file. So basically the plan is implementing some opencv thing in here because I'm gonna read the image via on opencv, but I do the filter via on the Cuda language. Okay, that's the plan. Also, I'm gonna reach this Cuda file via on this header. Okay, this is a basic plan I'm planning currently. Maybe we can start in the main CPP side. In here we basically first of all need to read the image. Image is gonna be just imread, and we are gonna read the Lena image. Okay, this one, and we are gonna read as grayscale because we are gonna apply Sobel filter, so we need as grayscale. Okay, this is the first step, and then we need to also for Cuda language, for using Cuda, especially in image processing, memory allocation is very important. So you also, there are two things important. One is the memory allocation issue. So you need to allocate the memory for the images. Also at the end you need to free them. And the second thing is that you need to transfer data from CPU, I mean device to device they are talking about, but basically from CPU to GPU, GPU to CPU. So this transfer is needed also. Yeah, this is two things important by using when you use Cuda language. Okay, also we need to define this width and the height. Okay, integer width is equal to basically just image dot columns, and just also height is equal to image dot rows. Okay, also for the allocation size we need maybe just image size, which is just multiplied by width and height. Okay, until here everything is clear. We are just getting width and height of the image. Also we are getting the total pixel number into the image size. This is all clear until now. Also we need to create the unsigned char array because for the Cuda cannot take two-dimensional. Of course, we need to give as one-dimensional array. So it's gonna be the first of all just maybe we can call input image, and also similarly for output image we are gonna need. Okay, these two things we need to define. Okay, after this we need to first of all, as I said, allocation of the memory. Maybe we can write allocate memory. So for this we are gonna call Cuda malloc, but I think it's not gonna recognize first of all because we didn't define this. Maybe we need to define in here. Okay, the function, the library is just Cuda runtime, which is the general library used in most of the cases. So this is gonna be helpful for us. So similarly we need to add, okay, we already added here. Also we need to add to main CPV side so it can reach to there also. Cuda. Okay, Cuda. Okay. This one. So now we can reach to the Cuda malloc. Okay, still it cannot because I don't know, but it should be something like this. Yeah. So in here basically we just need the, we need to give this one, maybe no, this one. Okay, it doesn't matter, both similar seems. The first thing we need to give the allocate for the input image, which is gonna be the input image, and also after that we need to give its size, so size t, image size I mean, and similarly we need to do for the output image. So first of all we need to allocate the memory for both images. Okay, this is the first step, and then we need to copy this. For example, now we only get this image. We need to copy this image data into this one, this input image, but we need to transfer also from the CPU, because this image still in the CPU side. We need to transfer it into the GPU side. So transferring image, maybe we can call in here transferring image. Okay, so how to do this? Just calling Cuda mem copy, memory copy. Okay, this always coming lately, but the name is basically just Cuda mem copy, I think. Okay, the next one is, first of all we need to give this input image, because also why it's not suggesting me. Okay, we can go to this function to understand more clearly. Maybe I hope it will go. Okay, in here basically you need to give the destination. Our destination is gonna be the input image, which we are already allocated memory also. So the second one is gonna be our image, which we read via on the opencv side. This count is gonna be the image size, because this is gonna be the including all the pixel numbers. And at the end, which kind of memory copying. For example, in our case, we are gonna copy from host to device. The name maybe we can reach. Okay. In here the types. So we are we are the host. The device is GPU. So we are gonna use this one. But at the end, after GPU process is done, we are gonna use device to host, which is this one. So these are the some terminologies in the Cuda side. Okay, so the second one is gonna be basically just the output image. Oh, sorry, not output image, but image dot data, which is gonna be the same type of the unsigned char array. And then we are gonna write the image size, which is the count of the pixels. And at the end, we are gonna use the basically just Cuda. I hope it suggests me. Okay, from host to device. So this is the last one. So basically we just transferred image data into the image, input image, which we declared here. And also we are already done. So GPU can reach this now. Okay. Then the other thing, maybe the most important one, also one of the other most important one, we need to declare some dimensions, because we need to do this because in the Cuda language documentation it says, because we are gonna use these things to transfer some data, it's a mandatorily you need to give this two dimension into the here. For example, this grid size and the block size accordingly. This is another terminology in Cuda. One of them, for example, we can talk about the grid size is just the size of the image. For example, columns and the rows, we can basically say. And block size defaultly is 16 to 16 if I'm not wrong, but it can be changeable. I'm not really familiar. In here it's written specifies the dimension and each size of the this kind of about the threads, but default one is gonna be useful in most of the cases. Okay, so we can define block size as dimension 3. This is gonna be the block size. I think defaultly it's gonna be not here, it's written. Okay, anyway, but defaultly I think 16 to 16, or we can directly define like this. Okay, then the next one is gonna be the grid size, and this is we need to put as width to height, because 512 to 512 I think. So our image sizes, let me check one more. Okay, so I'm just putting this width and height into the here. Okay, this is the other step. Maybe I don't need to define even, it's gonna take the default one. The next is the next step is we can anymore use the we can use the Cuda, we can use the GPU now. How to do that? I'm planning to do Sobel filter in here. So basically maybe we need to call Sobel filter. We can define a function. Okay, and this function of course gonna take some parameters. For example, basically most of them is unsigned char will be let me think. Okay, but it's gonna take unsigned char. Okay, then this is gonna be the input image. Also it's gonna take output image similarly, but this should be constant maybe. Okay, because this is not gonna change, of course. Output is gonna be changed. Okay, what else it's needed? Also it's need width and height of the image, I think, because since this is gonna come in one dimension, it's gonna need width and height also. Okay, I think this is gonna be enough. Of course it's gonna be void, and I think done. So we are gonna give the input image, we are gonna get the output image via on the main CPP side. Okay, just refactor this into the Cuda file, and inside this actually we just gonna create another function in here. Because why we are gonna do that? Because Cuda only can use the the GPU can only use the functions starts with global. So this is another thing to learn about the Cuda language. So all the functions should start with this. So otherwise GPU is not gonna run the functionality. So this is another thing to know. So another global function we need to declare here. So we are gonna make all the things inside this function. So we need just main CPP is gonna call this one, and this one is gonna trigger this global function, Sobel filter function. Okay, so Cuda Sobel filter maybe we can call, and okay, so this is gonna take basically just similarly taking these things, I think. Okay, and I think this is also done. So we can create this function. I think all is done. Okay, what else? Also we need to declare the kernels. So Sobel is using basically just these kernels for GX and GY. These are the gradients kind of. Also people who are interested to know about details of the Sobel filters, they can check my filter 2D or Sobel filter functions function videos in my YouTube channel. They are old videos, but they can still check, because just simply these kernels is gonna travel all the image, is gonna multiplying. So at the end there is a formula. So sum of summation and square root kind of operations, and at the end all the pixel values is gonna change according to this kernel. So some kind of kernel multiplication we can say, but we are gonna use this gx and gy. Okay, for them we need to also declare according to this these constant Sobel filters. How to do that? Also constant is written like this in the Cuda language. So basically we just need to define for Sobel x, which is gonna be 3 by 3, of course. This is gonna be just array simply, because if you not define this kind of the global inside the global, you cannot reach these arrays. So this is also another important thing. So basically just is equal to, okay, and after this we just need to define the numbers. So for example, for the x1 minus 1 0 1, if I'm not wrong, okay, minus 2 0 accordingly. Let me write, let me just copy here. Okay, one more done. Yeah, this is for the Sobel x, but similarly we need for the Sobel y. So these are gonna be the kernel arrays. So basically the second one is minus 2 2, and the last one is minus 1 2 1. Okay, so same. Yeah, for the Sobel y is just opposites kind of. So it's just starting with minus 1 minus 2, and it's opposite or the same, doesn't matter. We can do like this also. Second is 0 0 0, all is 0. Okay, and the last one, why this is wrong? Okay, and the last one basically just 1 2 and 1. Okay, so we defined our kernels. What's wrong in here? Why it complains? Okay, so just basically this one. Okay, we just defined our kernels, and so we can now define the Sobel filter inside this function. This part is gonna be a little complicated because basically I'm just gonna make some operations, which is just you need to imagine, because this data is coming as 1D, not 2D. So we need to in some way this 1D pixel values we need to multiply with these kernels. So I'm gonna do this operation, but let me try to explain by one by. So basically in here there is gonna come some block ID and block dimension kind of things. This is also, I'm not very familiar, but just this is the sum. Another thing we need to know, not this, times and block dimension dot x. This is gonna be, I'm gonna explain after finishing this one. Also similarly for the row. Okay, this is x, I think column is x, and the row is gonna be the y. Okay, so this is kind of thread you can think, because so the pixel values for each pixel value, each coordinate is not gonna come into the here by one by. So it's gonna come messily, it's not gonna come in an order. So this is kind of thread, but for each pixel inside the image is gonna enter here. For putting some kind of printf, you can also visualize that, but this is gonna come for each pixel to this function. Also we can try after this is finished. So this column and the row number is just representing this part. Do not focus much, but it's just doing giving you the coordinate of each pixel. For example, a pixel came into the here, it's just telling you the column and the row number of the image. These are the some declaration in the Cuda library also. This is the one thing you need to know. So these are the x and the y axis of the each pixel coming into here. So we get the pixel values, pixel coordinates, but also we have the input image, so we can directly reach into that pixel index value. This is the logic. So we already know everything inside this function anymore. This is the one thing we need to know at the beginning. Also for Sobel we need to of course know this, we need to calculate at the end this gx and gy values, which is gradient x and gradient y, some kind of formulas, and we need to make a for loop, and in two for loop actually we need, because since this is 1D, but we can start with I is equal to 0, I is smaller than 3, because 3 by 3 kernel we are gonna apply, and I plus plus. Okay, this is the first thing, and this is the first for loop, and similarly we need one more for loop, which is gonna be the other axis of this Sobel kernels. It's gonna be J, and I think all is done until now. Okay. So the next one, we need to, for example, 1 pixel is gonna come into here. So for that 1 pixel, we need to get around this pixel. For example, let's say the pixel value coming in here, coordinate is 33, 34, right? But for this pixel, we need to apply this kernel. We need to know this pixel values 32, 34. Around of this gonna be the center, which is coming pixel value, and around that we need to know 32, 34, let's say also 33, 34 we need to know already, 33, 35, and this is only the first line, and up of this okay, 31, sorry, so this is the x-axis, y value. Okay, so we need to similarly know 33, 33, so 34. Okay, I'm lost also, let me explain in here how to explain it. Okay, let's assume this is our image. So this pixel if coming, we need to know around it, around of this pixel value, this 3 by 3 math, because we need to multiply this value with this kernel, right? This is the mathematics I want to explain. So this is our image, of course not like this bigger image, but for example, let's say this coordinate is coming, but we need to extract from image this 3 by 3 matrix. So after extracting this, we need to multiply with this one. This is the logic I'm trying to explain. I hope it's not really complicated. Okay. Now we know this is our pixel value. Basically, we need to know for each loop, we need to know the new corresponding pixel value in our input image. Okay, we can call image row, because I don't want to make complicated with this one. So so this is basically just row plus gonna be the I value minus 1, because I, for example, is coming 0, so row plus 0 is row, but minus 1 is gonna go to the previous pixel. For the 3, it's gonna go to previous pixel also. So I'm gonna include all the pixel values around this coordinate. I think it's not complicated. Just little thing about this you are gonna understand. Okay, image column is equal to similarly just column plus j. Yeah, it's not I, j this time, and minus 1. Okay. This is for the column. So now I'm gonna reach all 9 pixels around this center coordinate. Okay, yeah, that's all. But even since this is coming at thread on the edges, I don't want to make it crash, so I need to check, because we know the image row is the new coordinate. This should be bigger or equal to 0. Otherwise, don't enter here, because it's gonna try to reach a pixel value which is not exist. It's gonna crash maybe. Yeah, this is a check we need to do. Okay, this image row, and after that also we need to check if this should be also smaller than height. I think row is the height. Okay, then also similarly we need to check for the image column, should be bigger or equal to 0, and at the same time it should be also smaller than width. Cannot equal to width because it starts from 0. Yeah, that kind of reason. Okay, so in here basically I think almost we are done. Just we need to, if it's entering in here, this is a valid coordinate. All I need to do is just gx. I need to sum for all the you need to know little how this Sobel operating is working. So basically it's just multiplying, summing at the end, then square root we are gonna take, kind of that operation we are gonna do. Okay, what is next? We need to get the Sobel x, and in here we need to get I and the j value, and after that we need to multiply with the real image, I mean the input image coordinate. How to do that? Here also gonna be little complicated maybe for you, because basically we know the image row. Okay, image row, and this is times width and plus just image column. So this is gonna go into the corresponding pixel value. Since this is coming 1D, in some way you can think in your mind this is looks like trying to reach a 2D array, but this is the way if you wanna reach y on 1D. So I'm reaching to the corresponding pixel value just. Okay, similarly I need to do for the gy, Sobel y. Of course this is gonna be the column. Okay, height and row. Okay, but wait, so since this is gonna be the same, I shouldn't change here because I'm just reaching to the same pixel value. I'm not changing it. All I need to do changing the Sobel. This shouldn't be changed. Sorry, I think so. Let me think again. So why I'm reaching somewhere else? So same one should be okay. Anyway, if so at the end, if this for loop finishing, then I need to just output image assigning new pixel value, and here is gonna be the how to reach. Similar logic I'm gonna use, just row times width, okay, plus just column. So the same logic I'm using for here also, and this is gonna equal to in some way just square root of, I think Cuda has something like this, squared f better. Then in here I need to just put gx times gx plus gy times gy. So this is the last step of the Sobel kernel, Sobel filter. Okay, after this we are done, but I need to be sure this is coming as unsigned char, because this is unsigned char. Okay, so similarly I need to cast this one, maybe static cast is gonna be better. So the unsigned char is gonna be, so I need to just paste it back. Okay, this part if you learn here you will never forget. This is a simple logic. Okay, just I'm reaching to the corresponding coordinate. Here I don't know the details also, they are just using this way to reach to the corresponding coordinate. Kind of complicated to me even, but they are reaching in this way anyway. We defined our kernels, so image is gonna come, we are gonna reach into the each image. We are already make ourselves safe by using this if, so it's not gonna try to reach somewhere not exist. Anyway, at the end it's gonna apply, so this is gonna give me the output image. Anyway, this is not important for us. Go to the down. So in here we are gonna call our function. To be able to call also you need to use this definition. You cannot directly call Cuda functions. So basically we need to define, let's say, Cuda Sobel filter, and what happened? Okay, so you can give inside, let's say, input image, output image, width, and also the height we need to give, but I'm thinking about the other side. Anyway, let's see. Now we need to put this, but seems we forget something. We need to put something inside this dimension and the block size, of course, which we define in the main CPP side also. But how it's gonna take this? Okay, because it's gonna complain if we do not give that. Also, the Cuda kernel cannot be launched because it doesn't know the image size. So maybe basically we just need to give, I mean what I'm talking about, maybe these dimensions we define here, in some way we need to transfer into the kernel side. Maybe one more, not one more, even two more input I need to put, dimension 3, which is grid size and the block size. I think this is enough, the same dimension 3. So get here, copy paste here. Okay, so we get our dimensions also, so we can directly put in here. The first one is gonna be the what was the first one? The first one is the grid size, the second one is the block size. So we need to give grid size, yeah, block size, and now all is clear. Yeah. Even little complicated because this kind of formulas sometimes I'm losing myself. Just, yeah, I hope you understood. Basic Sobel filter, even simple, explaining in some cases not easy to explain. Yeah. Anyway, all I need just calling this function now. In main CPP side, we can just need to create an object of this Cuda function class. Okay, Cuda function, and just calling Cuda function dot Sobel, call Sobel filter. In here we need to give our basically just input image, which we defined already. Then also we need to give output image. Also we need to give width, we need to give height, we need to give, the first one is grid size, so we need to give grid size, and also we need to give block size. Okay, this is done. Then at the end we are gonna get this output image again. Also I want to run my function, but yeah, just want to run to see it's working fine or not. But I need to Cuda free these things, because do not forget, if you allocate something to free at the end, basically I just need to for input image, and similarly for the output image. So after this I can make run, at least I want to see it's not crashing. Let's see. Okay, exited with code 0. It means at least we didn't do something really wrong. It's working fine. Then the next one, after we are done with in here, I can create a new method for output. Okay, method out. Maybe I can define basically just calling the, creating the height and width accordingly. Okay, and this is gonna be the just unsigned char one channel image. Okay, this, I want to see my output in here. So the same logic which we are copying from CPU to device, host to device, the same logic we need to make again Cuda mem copy. In here we need to just do the opposite one. This time output image is gonna be the input, and then also but this time output image is gonna be the, no, of course this is gonna be the, this is before, this is yeah, this is, where is that Cuda mem copy? In here we this one putting output image is in here gonna be the field. Then this is gonna be source now, of course. So in here we need to put okay, this one is gonna be the, let me check this function again. So of course it's one, yeah, this one is gonna be my source. This one is gonna be the allocated via on this one. So this is gonna transfer the file. This is gonna be source. It's gonna fill out that data, of course. Yeah, data is uncharged because, yeah. Okay. Yeah, that's correct. Then just putting image size, and this time the opposite enumeration, which is just device to host. Where is that? It's not suggesting. Mem copy device to host. Okay, this one. Yeah, source, this one, image size same, this one is same. I think is correct, and we are done, I believe. CV im show result. I hope it will work. Out. Okay, just wait key 0. Let me check one more. We free the memory, we allocate, everything seems fine. Let's run. Wow, that's great. Then we did make no mistake. That's great. Yeah, so this Sobel you can understand from the appearance. Even if I see something Sobel operation output, easy to understand after you do many times, after you using many times Sobel, you can easily understand. If this is Kenny, it's also understanding easily because Kenny is more sensible, the lines. This is like kind of more bold lines. Yeah, okay, this is Sobel. So we did it. Let me check one more. Yeah, to summarize, this is all kind of Sobel functions, but basically the idea, any pixel value of any image you can reach in here, and inside this one everything is done by GPU. This is the main logic, and you can call it, you can trigger it with any kind of main C++ function. This is another thing. Okay, so but we are not yet done. I want to see the duration. C++ duration calculation. I always like to copy from somewhere. Okay. Okay, this is gonna be better. Just adding chrono into the main C++. Also, this part important because I need to tell you something about here. If I put into the beginning, and okay, this is in here. Yeah, before im show is better. So this is elapsed time in millisecond. Okay, I hope it gives me good result. Time duration. Okay, just paste. Let's see how it looks like. Okay, so this is kind of, if millisecond is bad, I think also. Anyway, I already created another example in opencv tutorials, I think. Yeah, this is already done. The same kernels it's using. Not directly I'm using the Sobel filter, but filter 2D is doing same thing. Also, you can check my filter 2D video. I want to copy in here this one also. Okay, this already done in here. Sorry, I already prepared here because at the end I want to show you the result. So this is also basically just giving the same Sobel filter of this one. Okay, anyway, this is giving in microsecond. Okay, I want to take this one. Why I'm getting that? Okay, in here how I did copy. Okay, and time also copy and put into the main CPP site in here. Okay, let's run Cuda test 2. Okay, you see the difference is huge. Why it's like that? Even opencv using CPU is just taking 6000 microsecond, but you see this is really high value. Why it's like that? Because in here there is an important thing needed to be told. By using Cuda, if you only use Cuda language without C++, it's good. So you don't need to worry about this transferring the images. But if you use together C++ and the Cuda language together, most of the cases it's being like that. But in this case, these things takes long time. Cuda memory allocation, transferring the data from device to device. So these are taking huge time. But if you only take the time difference this for the Sobel filter, which is gonna be the, just copy this one and put after the function is done. If you only calculate the Sobel filter, you are gonna get just very small number. But if you do the same thing for the opencv CPU usage, take this one, just even forget about the other things, just put after the filter 2D and take this time, and you are gonna see this is 100 microsecond, but this is 10 times higher than the GPU. This is the expected one, right? But as I said at the beginning, if there is an huge things to do, for example, there are some complicated image processing operations which in CPU really low, you can ignore the transferring time, because okay, this maybe takes long time, but the process you are gonna do in the GPU side is more huge things, so you can make the balance. But for small things, using Cuda is not efficient, because data transferring is an issue. But for the huge things to do, Cuda is better than the CPU side. So there is trade-off, of course, but if you only use Cuda, there is nothing problem. Everything is fine. So okay, this is the basic thing I want to show you. See, 10 times is high speed in the GPU side. I think this is done, but what I want to tell you, I want to show you. Let me create a Cuda. So people who don't have Qt, who don't want to deal with Qt, I want to create a Cuda file in here. Also, I want to show you how to run it. Okay. Basically, I need this one, copy and paste. What else I need? I need this Cuda function in there. Just copy in here. Okay. Just paste to here. Also, I need this one in the main CPP side. I don't need to call this object, but I need to directly call the function. Maybe just paste this one. Take here and okay, take here. So just take grid size to here and block size into here. Okay. So Cuda Sobel filter in here. Also, we need to include this Cuda header, which is this one. Okay. Remove this Cuda func. Anything left from Cuda func? Nothing. Okay. So this is the simple Cuda file you can create in your folder. So just open a terminal, and since this is not used with GCC, cannot compile with GCC, you need to use mvcc test.q output. Okay, opencv header not found because we need to edit also. So but you need to at least install opencv successfully. cflex and libs, I think, like this. Just run again. Okay, I didn't add opencv4. Okay, output image. Where is output image? Okay, we need to put, what's this? Okay, this one should be removed. Let's try again. I hope it will work. Yeah, that's great. So it's successfully compiled and give me an executable file. Just run it. Okay. Why this is high number? Let me think. Wait a minute. Okay, it's already working, but this duration, why taking long time? End time, duration, I think it's taking long time in here. Why it's like that? And we are just, let me run one more. Okay, at the beginning, why it was running really slowly, I don't know. Yeah, anyway, but after that it is fixed. yeah, but opencv, yeah, okay, we run this is taking 10 times higher. I think I'm done. This is maybe a little long video, sorry for that, because this explanation of here taking little long time. I'm also a student of this Cuda language. I'm trying to improve myself. I'm trying to learn more, because this is for the core level. This is in some cases is really important. So but the basic point, if you can reach each pixel of an image inside this function, you can do anything. That's the main point. So but we are already know that. Of course, there are some another easy functions in Cuda language library, but I'm trying to learn them more also. Maybe in the future, if I learn more, I'm gonna explain you also. Thank you for watching. See you in the next videos.